Well, Nate, it's 11. If you want to start, you can start.
There, man, I had to figure out how to get unmuted. Welcome, Agronomy Lesson 2. Appreciate your guys' attention. Uh, Unfortunately, as we put those things together in this agronomy school for thought, I will reference back to last week's material a few times when we talked a lot about balancing. So just a reminder to those guys that are on, if you missed last week, there is a recorded webinar out there. If you get a link to this week's video, and you need to have more information, that other link can be provided. Again, we're going after a couple of CEUs. I believe this one is one nutrient management and one crop management. You'll find that I am a corn guy. A lot of times I will talk these micronutrients. Now they impact corn, but also I try to go back through the slides and reference other crops and use the word plants instead of corn plant because of the 16 essential nutrients for plant growth. A lot of what we're going to talk about today is more theory, more concept, more overall view of how to manage micronutrients for higher yields. So the philosophies will work on multiple crops. With that said, again, just like last week, feel free to text and email questions if you find yourself having an issue unmuting or working the webinar specific information, phone numbers there, emails there, or if like Brian doesn't have my text up, but I know you've been texting Joe, text Joe or something like that, or text. If you're an invitee, if you're welcome to the platform as we get this out there, you can text your local guy. If you're one of Brian or Dean's guys, text them and they can get me the question as well. I've got a pile of information, not including the first two slides. We almost have 80 slides to go through. So with that, we are going to get started. We ended last week with this slide right here. It does not have sodium on it. Again, we talk about the 16 essential nutrients or elements. I guess we got to be careful how we say them for plant growth. One of the most important things is to understand how they work and where they come from. Carbon, hydrogen, and oxygen we don't apply typically to our crop, but we need them for plant growth. Also, I'm going to change your thinking of what is a macro versus secondary macro versus micronutrient. I hate calling boron, zinc, manganese, and molybdenum micronutrients. I can call them trace elements. A lot of times when you use the word micro, it's because, oh, we don't think we need a lot of it to make a big difference. Sometimes true, but a lot of times in soil amendment, we look at parts per million and we say, oh, it's a micronutrient. We don't need a lot. And that's starting to prove false as we move our yield goals higher. And we also are spending more time in more places of the United States growing crops longer and growing multiple crops. Case in point, we start talking about a rotation that includes a corn primary, then maybe a cover crop, and then a wheat, and then a bean, and then a cover crop, or a bean, and then a wheat, and then a corn. Guys, when the economics of farming change, guys look for the optimal rotation to be economically successful. And sometimes we're only looking at our primary crop needs, say a bean yield, but then you go out there and you throw a cereal rye or a turnip radish cover crop on there or whatever it is that you do. And then you complain about that not growing or not performing the way it's supposed to. And then you look at a soil test that says, well, we don't have any, let's say, zinc in it or cobalt in it or something to that effect. So just because we use the word micro, they are extremely important to gaining high yield and consistent high yield. So today's focus is just about the nutrient itself. The other thing that's very important, and you're going to see something like this slide multiple times because I will continually remind you that all crops to grain take some form of most of these micronutrients. So again, we spent an hour and a half last week talking about the importance of balancing, and the same thing goes here. That's one of the things we'll end the conversation on today, is about some of our specific products and how they perform. But it isn't me sitting there showing you a bunch of data that says Microhance is awesome or Hey Now is awesome. It's about showing you the analysis and how it performs multiple times in multiple areas, because they are balanced nutrient approaches. Just like when we balance up front our macros, nitrogen, sulfur, boron, or PK, right? Calcium, magnesium, all of those macronutrient applications on your farm are usually balanced with something. But then again, we'll go by straight iron and apply it. And so we got to try to start working towards a mentality or a philosophy that means that we still need to hold ratios and have micro and macros work together to be successful. 300 bushel corn is only out here not because it's a goal for everybody, but it does redefine a lot of the information for those guys out there that are either working to re-educate or continue to educate or working on their CCA. A lot of the information out there is from the 1960s, 68, 72, 75, a little bit in the 80s. These guys are 1982. But a lot of them are based on, when we're talking about nutrient uptake charts, are on the same science that was out there a long time ago on yields that they were getting a long time ago. That's why I always talk about these guys when I talk about corn, because what they were able to do is not only grow corn, but identify what that corn plant needed and when it needed. So these guys were the OG of starting to identify these uptake curves when they were starting to identify what's in the ground versus a tissue sample reading. And that's why they were pioneers in the philosophy of on-demand fertilization for higher yields. The other reason why I there's a lot of screwing up today. I apologize that my mind's going really, really fast and I'm trying to talk slow so you catch it all. And sometimes there's a hiccup there. But another reason why I show this slide in that 60 to 80 days after planting, think about the stage of that corn specific crop. But when we start identifying the amount of primary nutrients that one crop needs to sustain a high yield potential, there is not a whole lot of space in the soil, root explorer, or even foliar for very many other things. That is almost, I'll let that sink in a little bit. That's almost 30 pounds per day, right, of nutrient uptake that we're asking that plant to do daily for a run of almost 7, 10, 12 days. So we want to look at things like sulfur and boron that are soluble, leachable, move through, mixing them with nitrogen, because then every 11 pounds that plant takes up on nitrogen, it also gets sulfur, boron, phosphorus, right? We talk a lot about phosphorus zinc ratio. Why is that so important? We keep those ratios available so that phosphorus and zinc work together, so that when it's taken 3 pounds a day of phosphorus uptake, right, if our ratios are well and we have that sulfur zinc interaction, we're helping that rider into the plant. A lot of guys say 1982 was a long time ago. This, again, on the macronutrient study, was all reproved in 97 and 2013. Iowa State, University of Illinois, Penn State's another good one, and Michigan State, actually, for multiple crops. I think I saw Steve was on here. For multiple crop research, does a lot of micronutrient. And then I'm not putting a plug in for him, but the hands-on agronomy book of Neil Kinsley gives you a lot of information on the fruit crop needs of certain micronutrients, tomatoes and copper and shelf life, um, spring lettuce, things like that. So there's multiple information out there, but this is just one shot of, right. They've redone it. They've taken a look, and we're still finding in that 60 to 80 days after planting, we're still forced to take 40% of our nutrient macro load up in there. This is just another way of looking at this. You're going to see today that not everybody that gets an opportunity to be exposed to these webinars, me included, learns the same way visually. So you're going to see the uptake charts. And then I've also put a lot of the uptake graphs in there, because if you respond or understand a bar chart better than you do a curve line graph, this gives you the opportunity to find that aha moment either way. So same information, just looked at differently. Again, though, a lot of research, a lot of time, you go to your co-op websites, your apps that are available on crop removal, essentially what they are doing, and you see P205, K2O, a lot of times they're looking at, well, how much MAP, DAP, potash, 32, zinc sulfate does that crop need? And we are at the luxury in our business model of working with growers to sustain higher yields using good available nutrient sources that are heavily chelated. We don't always have to put a mixed blend out there of nutrients. And we're not after how much MAP does it take. We want to know how much phosphorus, how much potassium, how much calcium. The other side of this too is, as you look, the other reason why I like this slide here is we talk a lot about corn, soybeans, and wheat as primary crops in the rotation. But we also, remember I mentioned the fact that micronutrient is not a very good label for these, because yes, at 180 bushel corn, there's a big difference from the nutrient per bushel need of one to the other. But when you start looking at the sulfur, the boron, the magnesium, the manganese out there, a lot of those numbers are essentially the same. And I guarantee you, when we looked at all of the soil samples last week, your eye is drawn to certain things that you think you can control. And when we make product recommendations on our primary crops for our plan, are we always treating those micronutrients the way they're supposed to be treated? Because a lot of these charts would say that, man, if you're running 3 gallon of boron on your corn program, but only using a quart of manganese, we are missing the boat. Same as when you look at your soil part per million availability on a soil test, boron versus manganese, if you're not essentially the same or almost higher, you are missing the boat. So that's what I want you guys to take a look here, is saying, oh, well, 0.17, or if you double that 300 bushel corn, 0.25 or 0.3 or 0.4. I don't want you to think, oh, they're micro because we're not using a lot. I want you to take some time to digest a slide like this. You can get these slides in your own area from your own university, from anywhere that posts that. You can get these slides from other places, but I want you to start looking at this bottom half of this chart and understanding the plant uptake needs, because same case with soybeans, we might put a little zinc in our starter, but then never put any boron on our soybean program. And then you see these high yield guys are popping out with these foliars and multiple applications. Well, on paper, in science, right, a soybean needs just as much zinc per bushel as it does boron per bushel. So I think that's one of those huge takeaways, that I just want us to prioritize these nutrients, because the real answer is nitrogen, phosphorus, potassium, and sulfur are usually going to determine your yield potential. And if you don't get those right, you won't be able to maximize return. After that, normally calcium, magnesium, not just only on the base saturation, but also available calcium, magnesium, dictate where we go next. And then after that, you can kind of re-identify your hierarchy based on your soil availability, what kind of soil. Same thing here. As we get into the individual nutrients, you'll learn some of these are leachable, some of these are immobile in the plant. I can feel very confident that building soil levels of zinc, if that root can find a space to grow through it, right, is a value to that grower and a good spend. Adding boron to watermelon sand early in the season doesn't always guarantee at tasseling time it's going to be there as a leachable nutrient. The other thing that I have all three of these on here for is I want guys to understand that when we are identifying the relationship between soil sampling for information as one tool in our toolbox, tissue sampling for information as one tool in our toolbox, and then working towards crop removal or yield goals to identify how much nutrients I need to get there. Micronutrients sometimes influence other crops that are planted thicker in the ground. Case in point, wheat. You put 1.4, 1.5 million, 1.2 million seeds out there. You got a guy planting 60, 70 to 90 pounds of wheat per stand. Think of all the plants per area that are intercepting that root mass, intercepting that soil profile to essentially uptake these micronutrients versus corn every 30 or 20 inches. Same thing with soybeans. When you got guys that are working to narrow up the soybeans to a 10-inch, 7.5 versus a 15 to a 30, micronutrient soil availability plays in the fact that the more roots you have, the more space you will that you consume, the better chance you have of seeing a plant response on those nutrients. And then you got to understand the relationship. And I need to be moving ahead slides, but this is just a good one for you guys to digest. The relationship of where we talk about these leachables, nitrogen, sulfur, boron, right? That nitrogen is going to essentially move 4, 6, 8 inches in your soil profile. We talk about phosphorus and the riders there with primarily zinc. That phosphorus is going to move 1/4 inch in your soil profile. We talk about potassium as a highly needed nutrient, especially in corn. That's going to move anywhere from 3/4 to 1.5 inches in the soil profile. So that's the other reason why we spend some time in a micronutrient conversation of redefining the massive amount of macronutrient uptake for higher yields, so that we can understand the relationship and the importance of timing of application, forms of application, so that we can take advantage of that plant when it needs those large macro increases. Because the one thing that a plant doesn't want to do, just like you as a human body, is a living, breathing thing, is be completely full of meat and potatoes and then have to make room for pie. And that's a simple way, elementary way of thinking about what we're trying to accomplish there. Is you don't want it to be completely full and not have room for dessert on the sundae or toppings. Law of the minimum. This wooden stave, this is not Nate Schroeder did not develop this mentality. This has been out here as long as I've been studying soil science and nutrient uptake, 30 years in the game. But I would like to redefine how we look at that. Again, a lot of our data is in that 180, 220, 150 environment. And as you move to higher yielding crops, and this includes wheat, this includes soybeans, this includes cotton, this includes sugar beets, this includes tomatoes, these relationships and ratios don't necessarily change on what's important, but what I need and when I do it, and the law of the minimum, right, or the one limiting factor does change significantly. So we know, again, that we have to address nitrogen, phosphorus, potassium, sulfur. We know that we need to work on calcium and magnesium availability and in its perfect ratio or ideal ratio for that soil. And then we can consider working on the other nutrients that we have. So going forward, when we're talking about nutrients and their impact to yield, I want to make sure to put the caveat or the disclaimer out there, right? If you have a base saturation 97% calcium, some of the things that I say and you go try might not work. If you have a base saturation of 22% magnesium, some of the things I say might not work. The other thing that when you look on these higher yields, you also see some of that unbalancing of where, hey, I have higher yields. I know I need higher calcium uptake to sustain those high yields. The problem is when you have excess of anything. And I will tell you, as you go to the year after, or I didn't hit my yield goals, or I over applied, micronutrients respond both to being applied and having adequate amounts, but then they also respond when you have excess other nutrients. Case in point, calcium. Extra calcium ties up iron, manganese, copper, and zinc to the tune of you can't apply enough amounts to make soil available, right? So if you know you're in a high calcium situation and you know that that calcium is tying up those specific nutrients, then you can understand that I will potentially see or have a higher percentage chance of seeing a response on certain micronutrient blends. Soybeans, right? We go out there and we lime. We lime every 2 years, every 3 years. We grid sample and we lime. We're using a calcium-based lime. My calcium level is there to adjust my pH. I get to where my pH is supposed to be, but I see calcium levels go from a 2,500 to a 3,500 to a 4,500 on my soil test. I all of a sudden see my soybeans go from 60, 61, 59, 48. And I'm trying to understand, well, calcium, I need calcium for soybeans. What's going on? Again, you're tying up hundreds of pounds, 500 to 600 pounds of iron, manganese, copper, to where you would have to essentially apply with that extra 500 to 600 pounds of extra calcium, you would have to apply 5, 10, 15, 20 pounds of these essential micronutrients to see those soybean yields go up. So again, relationships and understanding not only the value of making sure that you have the right nutrients to grow the crop that you're after, but to see response of micronutrients to essentially ROI them on economics, excess of certain nitrogen or certain nutrients won't allow that.
So Nate, while you're talking about that, then would you say that and a lot of farmers don't know this, even if they look at their soil test, but if you have an excess of different nutrients, then actually they're probably blocked. They're not being able to take up into the plant. So this is the case where foliar feeding, different micronutrients or elements might actually be an advantage for a short term till he fixes soil.
100%. Absolutely. The easiest way that I can explain that in a technical, we always want to be science-based. We don't want to be, well, one, this CCA or CEU unit is worth what you pay for it. And since most of you guys on here and that are getting the recording or listening to it for free, then make sure that the information that you're gaining from that is about worth that same thing. But specifically to Joe Dedman's question there, think about the effect of magnesium percentage on nitrogen use efficiency. Okay. And I'm trying to reach into my pocket and think the one thing that I wouldn't have to prove to anybody that listens to this webinar, if they've even done any soil sampling and any nitrogen management plans with anybody. The higher my percentage of magnesium goes, the more nitrogen I need to make a bushel of corn, right? So if you're 10, 12% on base saturation, I essentially on paper could be a 1-to-1. If I'm 13 to 15, you're going to be 1.2 to 1.3 pounds of nitrogen per bushel. If I'm over 20, I'm looking at a 1.5 nitrogen to bushel ratio. Okay. That's a known fact that you have to adjust your nitrogen plan based on percent magnesium percentage. Same thing what Joe mentioned. If I have a soil imbalance that is tying up all of the zinc all of the iron, all of the boron, all of the copper in my soil, then yes, more times than not, using good chelated and balanced foliar micronutrient plans will address that crop need. Because again, even though we call them micro, that doesn't mean that they're not important, but you do have the advantage of addressing the uptake needs of a zinc, manganese, copper, boron, and iron, moly, copper, or chlorine, nickel, right? The ones that are on there, you have the ability to affect that plant's uptake significantly as a percentage. Okay. Putting 1 gallon of 32 on a crop that needs, well, we just showed you 15, 18, 20 pounds a day isn't going to affect anything. When your plant only needs a skiff of an amount per day per yielding period, you will see an advance to foliar. So yes, that's why it's very important to be educated. That's why it's very important to be educated on maybe some of your soil sample data and your yield goals, because then you'll know what micronutrient packages will pay more often on your farm. Very good takeaway, Joe. Thank you for sharing that. Elemental prominence is a term. I used it 10, 12 years ago. I didn't coin the term, but I like it. Your plant needs certain nutrients. And just so that you guys don't think that I'm only talking about corn, each crop needs a different order. And within each of those crops, specific timings of each element it moves its way into the front line. You have different line leaders on different days of the week. I got a 5th grader, so unfortunately you have to hear about my kids on these webinars, but it's just like having a different, somebody always gets the opportunity to move to the front of the line to be important for that day based on what the crop needs and what stage it is in. Again, what does this look like on a bar chart? Exactly that. Stages on the right, certain nutrient needs on there, what it needs, when it needs it, how much it needs based on the stage that it is. So now, just back to Joe's conversation, we'll just use zinc, right? We'll use zinc, and we'll use the fact that I know if I've got a lot of calcium, that's going to tie up my essential soil sample or my part per million. So I take a soil, I'm 3.5, doesn't matter. If I'm high calcium, I'm going to tie up that zinc. It will not be plant available as much as it would if I addressed that calcium. So knowing when that plant needs zinc helps you identify when the best return of that foliar application, whether it be in a starter or whether it be in a foliar. I see on this chart that zinc isn't on there, so I should have picked something different. I apologize. Here again, you can't find me a chart that says a certain crop only needs 8 nutrients, only needs 10 elements, only needs hydrogen, oxygen, and carbon. I think that's another way to look at it, that, we know that the percentage of it, even though a 1%, even though a 2%, even though a 3%, you still need it in balance. I think the other important thing about this chart is we spend a lot of our time, because we can't formulate oxygen, hydrogen, and carbon for that plant. You can't essentially apply it to that plant. But if you look at the overall percentage of the entire nutrient spectrum, it is still a small significance of that plant's total weight. I like to use this slide to remind guys that weather, again, is always 70+% of what we try to accomplish. And regardless of how good your fertility plan is, no matter how balanced, no matter the micro, the macro relationship and the ratio and timings that you're doing, weather is still depictive more of yield than your nutrient plan can be. Understanding the uptake, and then we'll get on to specific nutrients one more time. You can see here, just like we talk about staging, certain nutrients the plant needs up front. 2/3 of the nitrogen pre-tassel it's taking, and that's not just making it up. You can see there, versus when you look at like a phosphorus, that plant is in a sulfur, right? Look at, it's more of a straight line from 0 to 100. You look at zinc, it uses about half up front, half later. Potassium, it needs a whole lot later. So that's just to get your idea around some of those different nutrients when the plant needs them, so that when we start to affect our application window on these micronutrients or these secondary or trace elements, we want to make sure that not only do we know the soil that we're putting it in so that the plant has it available. A lot of these nutrients aren't always on demand. They're not always in plant available forms. They're not always 100% soluble and need to be broken down by the biology in the plant. So you want to make sure that your timing windows reflect that. Boron, copper, iron, and manganese to finish out the spectrum. And also, when you look at these stalks, stalk leaf, leaf blades, tassel, and grain, it gives you an idea why you're putting it on there. That's why you start understanding why guys are maybe in high green snap areas, guys using manganese are seeing less response to wind events. More lignin in the stock, bigger, stronger stock. So not saying that you can withstand a derecho by using more manganese in your corn plan, but look at what it's doing. And as it spends all of its time on leaf and stalk, you can have stronger stocks. Same with copper, only different. So copper gives you the ability to have healthier plant tissue around that stock. So actually, a lot of guys in the high copper soils that have wind events find themselves to be a little more flexible. Beans, right? They can bend down, they can come back up, things like that in those high copper soils. So the other reason why those charts are important is understand, hey, is it going to just grain? Boron spends a lot of its time in the grain. It moves through the plant, but why it's there is if you truly believe that every kernel of corn you're pollinating isn't making it to the combine, then getting boron or making sure the plant has adequate boron as it pollinates through that 2-week abortion window is key. Same with soybeans. Boron makes bigger beans. So a lot of guys have a hard time getting beans in the size that they want them to. Let's say the weather depicts you to where it's a lot of 2-bean and 3-bean pod sets. Going out there with a foliar boron or some kind of boron application as you start filling those pods will help you get bigger beans after your pod set bean is fixed. Okay. So boron won't give you a 5-bean pod, but it will give you bigger beans in those pods. You wouldn't know those things if you didn't know this information. That's why this information is on. Does that make sense there? Knowing what the actual nutrients do per pertinent parts of the plant.
Yeah, pretty good.
So this wraps up all of that first conversation in words, right? So a lot of these guys that go through the webinars don't want to listen to me rattle on for an hour and a half, so they can scroll through the ticker and see that all this is up here to be the words of what we just talked to in charts. And also they'll remind a guy that yes, phosphorus is extremely important on the nutrient, but then look at manganese, boron, iron, zinc, sulfur, and copper are all on here because the secondary nutrients, usually that plant needs them both vegetatively and reproductively. So that again goes back to Joe's great comment. Couldn't have paid him for the plug of foliars, but that also goes back to why do sometimes in certain environments with certain products we see dramatic yield bumps or yield potential bumps. It's because the high yielding environment needs certain nutrients all season long. And that's very hard to do with the massive amount of uptake we are relying on the roots in the soil. Again, think of the crop. Multiple guys would say that my high yielding corn doesn't respond to foliar applications. I just showed you a pile of high yielding corn. The caveat on the charts that we just looked at, the color charts, that's on like 240 bushel corn. That's in there now. So we've recorded that. But as guys raise high yielding corn, the amount of uptake they need Absolutely, right? Y dropping and culturing and side dressing and making it available. But when we start to talk about wheat and we start to talk about non-row crop drilled beans, right? Sometimes they can explore more soil to get more micronutrient uptake, and they respond differently to foliars as well because there's more plant mass out there. You're getting more foliar distributed across that plant space. Now it is time. Oh, same thing there. There's the bar charts of the charts that we just saw. Thank Joe Dedman for pulling these out. University of Illinois. I followed them a lot. I'm going to fly through these just so you have them on the webinar so that you can see them. But again, 2/3 of the nitrogen up front. Phosphorus is important. Year-long sulfur, certain nutrients you need all the way through the growing season. Here would be corn. Here would be zinc, boron, copper, and manganese. Again, guys put zinc heavily in starters. Guys see a response on zinc in starters. Guys rely on the soil sample result of zinc to convert through the growing season to plant available. And that's where we see the response on that R3, R6. Not a lot of guys are going out there spraying a zinc compound on R3 corn, even though the plant needs a significant amount of that. By that time in the corn plant specifics growth, think about the amount of soil space it is exploring. So I'm not here to say you can't build micro levels in the soil. That's a waste of money because I just told you that it isn't. But I'm also here to remind guys that regardless of what their soil samples are, there's still a value to looking at your micro loads and looking at a foliar option. And manganese is an underutilized nutrient in both corn and beans, period. I think the one look out here is we talk a lot about nitrogen's important to high yielding beans. We talk a lot in corn where we went the nitrogen to sulfur ratio being 10 to 1, 8 to 1, 5 to 1. We talk about the importance of boron in that nitrogen sulfur solution, but yet we never talk about sulfur on soybeans as its relationship. That nitrogen sulfur relationship is still important, and finding a way to get sulfur on your high yielding soybeans has been a continued yield advantage for a lot of guys, both in their, the use of Liberty type herbicides that needs that ammonium sulfate rider to treat the water. Guys using a potassium source like a 4-0-2012 that has that sulfur rider in there early in the season, significant responses to that because again, it's a significant need.
On that chart that you just showed, isn't it fascinating that the amount of nutrients needed in that late growth stage, R5 all the way to R8, a lot of the farmers will give up at R1 and R2 and think it's all done, but it ain't.
The other thing that's not on this, and I have it identified as a nutrient as we talk about it, is moly. We haven't talked about moly yet.
Right.
And one thing that Joe just mentioned on these soybean slides is as we move into, we usually shut down around R6. We have seen an advantage on these soybeans in a high yielding environment, putting moly on, and not a lot of moly, ounces, right? Which is odd for us to talk about as a Monty sponsored individual because it's usually gallons and gallons, gallons, but ounces of moly on through the R6 stage and still seeing a response to yield potential on that. Again, we'll learn that moly helps us fixate nitrogen and look at the amount of nitrogen, like Joe mentioned, we still need to grow those soybeans, nitrogen and sulfur. So that's a great takeaway, Joe, is giving up too early is not always a recipe for success. Here would be these zinc, boron, copper, and again, manganese. Boron on beans is something that when we learn about these guys that are now cracking into the 200, the one guy cracking into the 200 yield environment, all of a sudden, yes, massive amounts of nitrogen, phosphorus, and potassium you need to support a large plant to put on lots of nodes so that you can have lots of pods. We achieve that now by obviously planting as early as possible that makes sense environmentally, using varieties that are fairly long in the maturity for the latitudes that we're growing them on, but also sneaking those soybeans down a little deeper into the soil profile so that the roots get a chance to explore more space, because phosphorus and potassium, including nitrogen, we just talked about where it moves in the soil is in that space. But then shifting gears on the zinc, the boron, the copper, the manganese, seeing those high yield responses, they're giving them on demand multiple times all the way through the R8 stage. So micronutrients do play in those environments. But again, if you've got a soybean that's begging for phosphorus R1, giving it copper on demand probably won't show you an advantage. The other thing I'm going to talk about here too, because it's important to mention, we do these things not because we're better than anybody else. We're just different than anybody else, but we try to get guys that have the opportunity to listen to these things, think about things a little bit differently. Myth busting. I think I got 2 texts last week after the first training, says, yeah, just keep busting myths. And I'm like, okay. Copper. A lot of guys are trying to justify fungicides on soybeans. A lot of guys are in the mentality that if I can put some copper on in some kind of form, it usually has some disease prevention attributes, or a high plant copper tissues test will give me some disease attributes. I have learned in the last 3 years that a good writer on copper is a call for sulfate form. We put that on significance. I wouldn't doubt that there's a sulfur kick to that soybean application in that R5 or R4 to 5 spin that we're not attributing to the sulfur that is highly available in those sulfate forms of micronutrients that we put down. Most micronutrients late in the season have some kind of rider. That sulfate rider is a great one for it, especially in soybeans. Same with zinc. Questions to this point? Literally now for the next 40 minutes, we're going to go through each nutrient. There's a corn plant here, but that doesn't mean anything. It's just going to talk about what it does in the plant. The pictures on the left, you can see some, we'll start identifying in the left bottom, will show some deficiency. I thought about separating those out, especially in the micros. There are better pictures other places. There are people that do a good job with those pictures, but these are busy slides. They're going to be up for a while so that you have a recorded option of these slides, but we're going to go through the actual individual nutrients on the left there, talk about what they do for plants, not just corn specific. Again, we just got done talking about the timing of those things. And then when that is over, we'll show you just sheer data of applying those nutrients, just as we talked about them, onto crop to see yield enhancement. So if you have got a situation where, as you see, we go down these nutrients where it's a boron, it's an iron, it's a copper, it's a zinc, it's a sulfur story, where you have a situation where, hey, this soil sample, this crop responded to this product, why, or yes, or I knew it would, or whatever, unmute, say stop. We want to hear those types of stories on this specific webinar. And then as we go forward, yes, Don just texted in to remind the Monty specific guys that nothing on here is mine exclusively. You can find these slides on the SharePoint, on the Monty SharePoint. Thank you, Don. See, Joe, I'm figuring out this technology.
Yep.
People chatting. Right, yeah, people chatting me, people texting me. Nitrogen. I shouldn't have to say anything about nitrogen. This title was micronutrients. I will tell you that it isn't so much important on nitrogen to know what it does. It's more important. It's more important that you know when you need more of it because of the soils and the situation that you're putting it into. Problem is, every time come on, there it goes. Plant growth, making kernels, 2/3 early. Guys are seeing response in corn a little later than what they thought on nitrogen. Forms of nitrogen, it is leachable. You are doing a good thing by trying to get your nitrogen use efficiency to where your crop is removing the nitrogen that you are applying for two reasons. One, you're being a good environmental steward of your local water table, reducing the amount of nitrates in the water by uptaking as much as possible. But also, two, you are building healthier soil because more biology can thrive in a situation or a soil environment that does not have excess nitrogen. We do not want a lot of we want enough nitrogen to feed them, keep them happy, but everything in excess tends to be detrimental, and excess nitrogen in your soil is soil biology detriment. Same with phosphorus as a macronutrient. Phosphorus is needed all season long, and it is needed in ridiculously large amounts. Primarily used in the starters, the pop-ups, the beginnings of the season. One thing I'll tell you about phosphorus and potassium is as you move to a managing the crop on demand, we have seen significant results in increasing yield potential by putting what we call a side dress wide drop type application, both in corn and beans and wheat, as a blended nutrient package. Not just side dressing nitrogen, but side dressing NPK and sulfur with some micros. Bringing that amount down, doing it more often will give your plant a more balanced diet, and you'll see a reaction there as it results to yield potential as it gets on demand phosphorus and potassium and not has to starve its ability to find it in the soil. P and K also, and go back to that first slide, right? We're talking 30 pounds a day for a 10 to 12 day, extremely weather dependent. If those roots are not growing through the soil, if we do not have adequate moisture and water, we will not take up the massive amount of nutrients. That's where we start talking about the ability to foliars having certain effect on plants in certain environments. You'll talk to a lot of growers, a lot of customers, a lot of prospects. Foliars don't work for me. The question is, what did you try? When did you try it? And what was the yield potential or the yield goal of that crop? Those three things will dictate your success on foliar fertilizers. Also, P has to be converted. Not all phosphorus is created equal. There's some relations as we talk about it. And then again, we want to make sure that we manage that zinc and phosphorus ratio. Also, high phosphorus levels in the soil affects our ability to uptake sulfur significantly. Again, I'm available for questions and calls, guys that are trying to raise high yielding soybeans. I think the more we learn about sulfur in late soybeans, the more we redefine the importance of, yes, phosphorus is extremely important. Yes, a soybean needs lots of phosphorus, but when we maybe are in an environment where we're over applying phosphorus, it's affecting some of our zinc and our sulfur that we need to grow those high levels of soybeans. Potassium is one of those things that we usually have a soil sample that says we have plenty of parts per million, but I encourage you to look at your base saturation of potassium. We want to get potassium in a level of above 3 to 5. maybe 4 to 6, depending on your goals. Also, I mentioned potassium is a nutrient that moves more than phosphorus, but barely. And potassium in the soil helps your water holding capacity. And we just talked about how important water is to get in all the nutrients of the plants. So those would be the macronutrients. We move on to magnesium and calcium. Most of the soils that we're working with, it's more about converting calcium and magnesium in the soil, converting magnesium to be plant available and to get some uptake. But magnesium as an element, as a nutrient, as a role is still vital in plant needs. Again, we don't talk a lot about it because of a lot of the soils that we're working with. It's more of a challenge of balancing, but it is an important nutrient. It also does not play well with others, is why you don't see a lot of foliar blends with magnesium in it. I spent a little time earlier, I guess we kind of talked quite a bit about sulfur. Again, sulfate sources are immediately available to that plant. So you can see a significant increase. Nitrogen to sulfur, we talk about how the micros play with the macros. I would encourage you in the corn and the grass crops, wheat type things, instead of looking at that 10 to 1, 12 to 1, 15 to 1. Some guys now are down into that 4, 5 to 1, 4 to 5 to 1 with some success. Also, sulfur and wheat, like a 2805, or when you're using your 32 blended with sulfur in your corn, a lot of the high yielding wheat, if you could get just in most scenarios, just an added, if all things are equal and almost ideal, an added of about 10 to 15 pounds of elemental sulfur to that wheat crop, if available, will be like 5 to 7, directly 5 to 7 more bushels of grain. So sulfur as a nutrient is significantly important there. Now we'll start talking about ones that that you guys got online for, because the true ones by definition as micros. Again, with nitrogen, I guess there's some ratios that are recommended on this slide. I didn't make this slide right here, so those would not be my ratios. And then as leachable nutrients or nutrients as it goes, sulfur competes just because of the high needs there through calcium as a nutrient is significantly important in moving all nutrients up through the plant. You think of it as a highway. If you can put a 4-lane interstate through the middle of your corn plant versus a 2-lane northern Missouri asphalt road, you can move nutrients more efficiently. We could do a whole hour and a half on just calcium. If that's not why you guys came to the slideshow today. I will say that I do have some slides in here. We are working with better how do you say, better products of calcium. Calcium and phosphorus don't tend to play well in starter, but that's when you need it. We've identified some opportunities for most growers to investigate the opportunity to still get calcium out as part of their nutrient plan, and that has showed some great results where we continually get soil samples that show calcium part per million in the 38 to 4100, and yet a calcium tissue sample that shows that we could use a lot more calcium. Again, too much calcium is not a good thing. Really work with your guys, again, referring to last week, to identify what nutrient imbalance is driving their pH, potentially magnesium, potassium, or sodium, because just using calcium to get your pH what you want sometimes creates you to over apply or have excess calcium and excess calcium affects sulfur, iron, zinc significantly. And I don't know how much time you guys research these on your own. I'm kind of a nerd for this, so I spend more time. Boron to calcium ratio, start with 1,000 to 1 on a soil sample amendment, and then go from there. 500 to 1 might be something if your CECs or or your magnesium base saturation is a little higher, but calcium to boron synergy is a real thing. Problem there is it's easier to build calcium levels in the soil as it is boron, especially as it a high leachable nutrient. But just something to think about as you amend those soils to get ready for your micro applications. That calcium boron 500 to 1,000 to 1 is a good place to start. Again, micro and macro relationships. I was down in Texas this last week, hanging out with Rodney, meeting some guys, talking about corn production. I found myself in a meeting the other night talking to a guy about the 3 things that he could do to increase corn yield almost anywhere in the world. Boron is probably, if not number 2, the most efficient nutrient found in any soil sample anywhere. The 3 things you could do, I told him, is split up your nitrogen, add boron, and add zinc. Those 3 things alone, right, in any order, usually on a grass crop, will put more yield potential out there. But again, what do we know about boron? Boron is highly leachable. I have stories of guys on those high sand areas and irrigated worlds where they try to put a boron application out in the planter with their nitrogen sulfur boron ratio and a dribble over the top or a 2x2. And by the time we really need that uptake curve to show boron, it is no longer available because it's been dry and we've had to irrigate 6 or 7 inches by then. Boron moves. Boron is highly leachable. You think nitrogen's leachable. You think sulfur's leachable. Boron moves. The nice thing about that, though, is boron responds when we give it to the plant. And just like Joe mentioned it, looking at the later stages, right? Boron responds more often, and we have a large window to put it on, typically in a corn time plant, anywhere from V6 beyond. Foliar, soil applied boron, we want to make sure it's there before that V6, V8 time so that the tasseling plant has boron. And the one takeaway from all the things that boron does is, again, if a tasseling or fruiting plant has sufficient boron, you have a better chance of putting the pollinated kernels into your combine. Okay. With soybeans, we talked about its advantage of making bigger beans. Also, we talked about boron's relationship with calcium, right? That 1-to-1 ratio, boron also helps you get more calcium into the plant. If we're raising certain crops, that affects our boron levels in the soil. Corn and wheat grass crops, like we already talked about, we want to see like a 2, maybe a 1.5 to 2 part per million. Soybeans, if we're under 1, I'm not scared on a soil sample. But when you go into like an alfalfa leguming type crop, you'd really like to almost see like a 2.3 on a soil sample, ideal to put alfalfa in for boron specific. Potassium, phosphorus, and calcium, again, micro macro relationships. And then 2 slides on yield. This first one was back in 2010, and you can see that just putting any boron on at a pint, which is not a lot, was a 5 bushel increase. That's old data. 10 years later, adding boron to a crop will still increase yield. Soybeans here, obviously we used a fulvic to increase our opportunity. But boron on crops tend to pay significantly if we're putting them on the right stage for the right reason. I'm a fan of more boron. Chloron is one of the essential nutrients. So here is your information on it. Typically, our application rider, as in water, at significant enough gallons throughout the growing season, or irrigated is enough for our plant to need. It's important to test those things, application water and such.
The big one there is that murate of potash.
Yeah, yes,
Or
thank you.
they don't understand, farmers don't understand how detrimental that they have been putting on murate of potash for all these years.
Yeah, not too much of a good thing, right? Is not what we're talking about here. This too much in excess is extremely detrimental. And it significantly affects our ability to balance that soil.
Mm-hmm.
Because the one thing about, like you had mentioned, the copious amounts that they are applying in those types of forms, I can't just grow out because we don't need a lot of it. That's a great takeaway. Yeah, certain forms. Yeah, and that's a great point just to take away as we talk about some of these nutrients specifically as individuals. It's up to you guys to take this information and go back to some of the applications or macro products. Why did we spend the first 40 minutes talking about NP and K? Is because 90% of the data out there on high yielding crops is put on more NP and K. Well, I will tell you, depending on the form you're using, when you're putting on, and how you're putting it on, that's going to affect your ability to advance these micronutrients into most plants. And I will sit here and tell you that in a balanced, ideal situation where we can have decent weather, these micros will pay you more yield most times if NP and K are addressed appropriately, not in excess. So that's a great takeaway, Joe. I truly believe that manganese is maybe a little underutilized. It does a lot more than maybe what most guys think it does. Highly involved in the photosynthesis process and chlorophyll. One thing to think about ideally, if we had nothing better to do and we could just in a lab apply all the nutrients when we needed it, why we knew it. A lot of herbicides tie up the plant's ability to move manganese around. And so either as a tank rider or as a separate application, you see the ability there of manganese to be applied and have an advantage there. Because it's not necessarily translocated in plants. It doesn't move a lot. Deficiency will be on the youngest leaves, kind of backwards where you see some of the macros, right? The MP and K, or on the oldest leaves or the bottom of the plant. A manganese deficiency will show up on the newest crop growth. Heavily tied up with too much calcium. A lot of guys are trying to work it a little bit into their starter or pop-up type programs. It's a nutrient that does have a little bit of we use the word hot to it, but you can definitely get an acceleration of germination to it, essential for that grain formation. Builds a lot of protein. And then it also, if you're talking about the importance of it to a legume or a fruiting or flowering plant, you definitely get more fruiting and ripening rapidly. We talk about building it in the soil profile. This is we talk about that one slide that had kind of all of the needs out there for crops. I would say that if I had to give you a number, something to shoot for would be like into that 80 to 100 parts per million. Is a great way on a soil test to help see the advantage. And then used heavily in a lot of gardening. If you've got a grower that prides himself on farmers markets, tomatoes, broccoli, onions. A lot of garden crops respond heavily to a little manganese. Again, I showed you the uptake curves. We specifically look at a boron and a zinc and don't spend enough time getting manganese when we need it. Again, here like Molly, in order to have a high yielding soybean make more of its own nitrogen, because we know nitrogen is tough to apply on a soybean without burn, manganese is a good rider for that. Moly and manganese, boron and sulfur on high yielding soybeans, as long as NP and K, calcium and magnesium are addressed, will always lead to an advantage. I cannot stress that enough. We're talking about manganese, moly. They're just because, again, I hate the word micro and I've used it a lot. Just because they are needed in smaller amounts more often, that does not mean that they are not extremely important to the yield potential of your crop. Iron, corn loves iron. Francis Childs, 400 bushel benchmark, Northwest Iowa. One of the stories that were always told about his root digs in his plots where I think they actually had core iron in them, like you could see it, you could visually see iron veins through some of his soil profile when he first hit the 400 bushel benchmark. I remember that story being told as a kid. Iron's one of those neat things in lawn and grass. We like it as a 924-3 rider for soybeans because iron's nice on your lawn. If you learn how to use iron in the right form, you can make your lawn greener without making it taller, so you don't have to mow it as often versus a nitrogen or a sulfur application. And for a guy that doesn't like to mow, that's important. Also, you can see up there the importance of balancing the microspectrum to make sure that iron deficiency doesn't show up. pH directly affects iron. We did some availability slides last week. I encourage you to go out there. We're not talking a lot about that on these nutrient spectrums, but available iron is affected dramatically by pH changes. Chlorophyll. So when you see like soybeans, sorghum, I think Steve's continually getting on there. Citrus, peas, sugarcane. Those iron deficiencies will show up directly in a lighter plant on those. And then also we talk about ratios. The one thing that helps eliminate iron deficiency is having adequate sulfur uptake. Again, being specific, where you primarily have IDC on soybeans and you can't adjust your pH fast enough to work out of that, and applying iron is just something that you either did in a form on the planter, or you don't have a good foliar iron choice. Sometimes increasing your available sulfur load for iron or for soybeans at certain times will help mitigate the yield impact of IDC. Learned here first. Molly tends to be expensive. If the economics of micronutrient packages never played in the marketplace, where guys didn't complain that you're 20 bucks a gallon, 30 bucks a gallon, 10 bucks a gallon, you would probably look to put a skiff or a slice of Molly in almost every micronutrient package. It's mix friendly. It's foliar safe, and it is an essential, an essential, as we call it, micronutrient uh, in most and all crops. The problem is it tends to be expensive. But just because it's last on the list does not make it not important. Again, Molly also doesn't need to be a whole lot. Ounces more often. Again, like we talked about in the staging of plants, Molly is one of those that as you continue to redefine what is your point of diminishing returns on application of soybean and corn specifically, you can go later, R6, R7, R8, with this Molly to continue to enhance that nitrogen fixation, the rhizobia bacteria to do make its own nitrogen. Joe, you worked a lot with Molly. I don't know, Brian. Has anybody used Molly successfully? Found a way to put Molly into any of their growers' plans?
I've just started playing with it, Nate, so I don't have a good stance on it as far as what it's done for me yet.
I've used it on non-nodulating alfalfa because of pH issues, like a Como Molly mix, and it works really good.
Thank you. Yeah, that's a huge takeaway. Again, we talked about a little bit about that with the manganese slide. Is sometimes pH dictates the ability of our plant to do what we want it to do. Same thing with the iron slide as we talk about adding soil to get away from that pH. Molly is a great opportunity to do that on an alfalfa standing crop. Also, when you're planting soybeans in some heavier pH that you're just kind of like, they tell me I can't do it, but I want some success with it. Yeah, for nodulating crops, great takeaway. You mentioned it, so we'll talk about it. Molly in relationship to cobalt and boron, both two real friendly tank mixes to get Molly into the plant on a foliar product. So yeah, the Como Bees type products are good ones for that. Thank you. More Molly more often. We're not going to talk about nickel because it doesn't matter. You're not going to do anything about it. We are going to talk about copper. Copper's fun to use because it's blue. It is the most immobile, as in it does not move. So you see response in multiple applications. We also talked about already about its opportunity to work against that disease spectrum. It's also very important again I'm going to take that whole, I shouldn't say specialty crop because all crops are special if you're the one growing them. But crops where where quality. So we raise number 2 yellow corn. When I bring my number 2 yellow corn to the elevator, it gets processed into hog feed and ethanol. They don't pay me anymore if my number 2 yellow corn is of higher quality. If you are growing a crop that gets paid on quality and shelf life, copper is your friend to do that. More sugar production, better seed production, food, flavor, color, and then we think about apples, we think about peaches, we think about citrus fruits, we think about tomatoes, onions, shelf life. Having adequate or ideal amounts of copper uptake into those type crops directly relates into its ability to stay better longer on the shelf. And then copper different than manganese. So obviously we know that if we have ideal potassium, we'll have better stalk diameter. Okay. Shouldn't have to prove that. We know that. Copper works with that potassium and manganese. As I told you, manganese helps us create more lignin around that stalk so that we have potentially a sturdier stalk in the event of a in a wind event. Okay. Copper helps when I say stalk stress, it's kind of like for old seed guys, heat stress and drought stress, right? Similar but different. Two different ways to look at what a heat stress core is versus a drought stress core is. Copper and manganese work with potassium on stalk strength, exactly how heat stress and drought stress is identified. Copper helps stalk strength, but it almost gives a little more flexibility to that plant so that it doesn't snap. And for our high yielding wheat guys out there, for our guys that are looking for more bushels, I think on the CBOT right now, wheat's still in the money. Copper out of all the things can actually be a limiting factor in wheat yields. And we don't talk about these micros as yield limiting very often. And with that said, you're looking at like 5 parts per million in a soil test to be adequate, and then applying it. And here's probably everything that I just said on paper. Sorry about that. Zinc, again, like calcium, is probably something that we could talk about for an entire hour. Most guys on a soil sample, we mentioned boron being almost the #1 deficient nutrient defined on a soil sample. Zinc is one of those things when you define adequate zinc in a soil sample being 9 to 10 parts per million, then you can argue with me that zinc is usually 1 or 2 of the nutrients that are found deficient on most soil samples. Some guys shoot for a 3.5, then they're not complaining about zinc not being adequate on a soil sample. I'm telling you, ideal standards would be 9 to 10 parts per million. We think of zinc as just a corn nutrient. That's not fair. By losing out on zinc in soybeans, you might not necessarily see the deficiency. It's not a deficiency that always shows up, but it's very yield determinant. So in the case of 1 part per million loss on zinc uptake in soybeans can result almost in 2 bushels. It's a 2 to 1. So if you're short 5 part per million on uptake in soybeans, you'll lose 10 bushels. Does that make that so we don't talk about that very often. We try to separate our zinc and nitrogen applications because high N ties up that zinc, high P ties up that zinc, and high calcium affects our ability to create plant available zinc in the soil. Zinc is very immobile in the soil profile. So again, you see, our wheats, our soybeans, things like that are more apt to find it in the soil profile because more root mass, more growing through it, higher populations, higher densities, more root mass on corn. So anytime you have a compaction zone or anything like that, that'll affect your ability to uptake zinc in high demands. Transportation of calcium through the corn plant, cell elongation. So we used to talk, or the old adage of, again, zinc early, quart of zinc in the starter. 2 things about zinc. When you're addressing zinc, either in plant uptake and in soil balancing, most zinc, 9-10%, chelated over the counter, weighing 11-ish pounds a gallon, guys putting on a quart. you're essentially putting a pound of zinc in a 6-inch furrow slice, almost 2 million pounds of soil. So when we talk half gallons and gallons, when we talk about uptake demand, when we talk about zinc and the needs that we need of zinc in that plant to grow high yielding crops, zinc quarts aren't really what we're talking about. The one nice part about zinc is you have multiple applications, dry, liquid, opportunities to put zinc out during multiple crop years. And again, we used to think zinc in starter was good enough. I will tell you that more times you put on zinc, the more advantage that you're going to get. There you are. High yields are impossible without it. Again, like copper in wheat could be a limiting factor. Zinc in corn and beans can be a limiting factor. I think, you know, the plant physiology guys would tell you how essential it is. Only defined as a micronutrient because of the small amount that you need. But at the same time here, I just told you that if you put a quart of zinc in your starter, and you're raising 240 bushel corn, I need almost, 3/4 of a pound or a full pound to achieve that based on my soil's balancing. I don't know if I necessarily can get that because I have to grow through it. More zinc adds to more yield. Also, its importance there, go back up, soybeans and wheat. Here would be 2008. The only difference here is I'm showing you that the versus the check, you did this one. The advanced ink would be a soil seed treatment in the starter, the foliar ZMB product, not ours that we retail, but just a data slide because we're third-party agronomy today, would show you that the more times we put zinc out, the more yield we get. That's on a 1.7 part per million. Okay. Again, I told you where ideal would be, but a lot of guys get into that 2.1 to 3.5 and think they have enough. Here again is a 2007 slide. The more zinc, regardless of the form that it was in, equaled more yield. Just another takeaway of available zinc to that plant throughout the growing season will make more yield. And those aren't small results. There's some 30 bushel, 25 to 30 bushel responses on zinc. This slide is backwards left to right, so it bothers me a little bit, but I don't know how to redefine the table. Checks far right, seed zinc, starter and seed, right? And you can just see the more times that plant has the opportunity to uptake zinc, the more yield potential. And hopefully, if Mother Nature cooperates, the more yield you'll have. Cannot express enough that zinc is only a micronutrient by definition because you don't need 15 pounds a day to take it up, but it is not important nutrient. And we're seeing some guys there on zinc actually moving it into more of their, we've talked about these other side dress application or these other micro applications, moving that half gallon to gallon of zinc all the way through their V6, V8, V9 application with return both on tissue sampling results and final yield. So again, it's important to understand. I mean, the one takeaway, this slide was a long time ago, but before we talk about these last three and get into data, a couple of things I want to throw out there is as it relates to boron and copper and manganese specifically, all those in a 100 bushel corn environment, that corn plant needs the same amount of those. as it results to zinc and iron and moly, those three nutrients are essentially needed in the same amounts per 1 bushel or for 150 bushel quart. Like the amount you need per bushel is the same on those nutrients, and we don't always treat them like that. Obviously, you guys can look this up, but hold the slide there. See it? Hold the ice there. You can see it. Some research here. I think this slide was already used. We're going to fly through this stuff here in the respect of time to stay on board with kind of what I promise here, for the credits. And then, if you got questions, see them. A lot of this is 19, 20, 22 data. So it's a little more recent than the 2007, 8, 9, and 10 data I wanted to show you. But again, that's just a matter of doing it early, often, and always. And then again, the importance of, as we strive for higher yields, as yield potential or yield goals go up on your farm or your customer's farm or your process farm, the demand of these secondary essential trace elements increases, right? We talk about that stave, that wooden bucket. This is why when you pick the right nutrient or right nutrient mix at the right time on the right crop, you can see significant yield bumps. Hey now trial. I think I've got a slide. I hope it didn't get hidden. Maybe it did. Of what hey now is, that's a that frustrates me. We're gonna try. Oh, I didn't get it. It didn't get added. If you bear with me here, we'll help you out. And this slide was supposed to be in the show. Thank you, Joe Deadman, for putting this together. If I can find the one specific slide I'm after. There you go.
Mm-hmm.
Thank you. This slide was supposed to be in there to talk about the importance of chelated nutrients in the products that you're using. Obviously, you're going to get some Monty product specifics here. But two things are important on this slide. Hey, now, as we use it as a product, if you look at the analysis, nitrogen, phosphate, potash, sulfur, iron, zinc, right? Some of these things we don't always know. I mean, we can look at charts, we can look at uptakes. The problem is with tissue sampling is it's always a hindsight mentality, right? We don't necessarily know that plant is begging for zinc until it's too late. We don't always know that is begging for copper or begging for boron. So the next slide you're going to see is the advantage of using good products that have multiple micronutrients in them. But the other thing that is extremely important is when we talk about chelation, and this is not a chelation education by any means, but when you talk specifically with these this segment of nutrients, not only is chelation important for it to be compatible and tank mix friendly, but chelation is important not only to not tie it up in the soil profile, but to make it plant available so that it can either get into the root or the foliar leaf surface.
Why don't you go ahead and go back into your slide mode, because I'm seeing all of your slides.
Oh, I did. You don't see that as a slideshow. Oh, I know, because on the share, hold on here. I can help you.
That'd be great.
Thank you for saying something. Now, can you see the hey now slide?
Yeah, we're there. Yeah.
Still work in progress. I appreciate everybody's patience. I am computer illiterate. I am a lot of things, but I am not a technical. So everything I just said, pretend you're rehearing it, looking at it. This segment of nutrients, as we apply them to either the ground, the soil, or specific to a plant foliar, chelation is important, the amount of chelation, the kind of chelation, because three things. One, tank mix compatibility, mix use friendly, right? Stabilization in the liquid form or however we're using it. Chelation helps. Two, tie up in the soil atmosphere. If we drop an unchelated nutrient in the soil, it's going to get binded with all these other ratios that we just spent the last hour and a half talking about. the calcium, the magnesium, the nitrogen. It's going to suck up that little bit, right? Because we are sprinkling, fairy dust, just a trace element amount at a little tiny bit. It'll get tied up and the plant won't be able to get it. So chelation third is extremely important so that we can get through the root grown through, or we can get through the leaf surface foliar plat. The other thing here is you can see that that availability of the of these products that we're talking about. I think I'll just stay here because I don't know if these slides transfer anywhere. Can everybody see these slides moving? Midnight,
Yeah.
Micronutrients, Noxon. We're going to talk about these, and then I'll go back and show some data through the other end. Potassium acetate with some humic. Not going to talk about that one. I was going to show here sulfur, nitrogen sulfur ratio we talk about, and how it's such an advantage. The only way I'm showing these is because you're going to see these on the slide, the data slides, and why they impacted yield when they did. Again, micronutrient package, Micronutrients. Look at the active, okay? Now, I'm not here to sell you Micronutrients and tell you that it's the best, but I also am here that we just went through an hour and a half of education on what each of those nutrients do when they do it. Not all of them do the same thing at the same time, and I can't necessarily go out there to your grower's field and say, uh-oh, looks like we're getting a little light on manganese. Uh-oh, in 3 days, you're not going to have enough boron to maintain your yield potential. So the importance of these chelated nutrients in a package gives you better risk mitigation when applying foliar to crops to address those tiny needs of that crop at certain situations. But at the same time, you can always go back to this webinar in the first 45 minutes and remind yourself when that plant is uptaking and needing the most zinc, when it needs the most boron, when it needs the most manganese, and then see if some of these built products, some of these combined products make sense for you versus applying boron on its own, manganese on its own, zinc on its own. Ingenia Enlist and Extendamax. Okay, we're going to skip there. I think we'll just use this for data. And the only reason why everybody can see the slide still, I didn't mess that up.
Right. You're good.
Boron. We already talked about zinc and boron and its ability to increase almost any crop you apply it to. If you're using the right amount, as in if you're using enough, if your soil sample shows that you're deficient, and if you are timing it, both those nutrients when the plant needs it the most. Those two micronutrients will almost, nothing's perfect and no silver bullet and no guarantee, but those two nutrients as a standalone will almost always be yield advantage. Then manganese, copper, moly, and then in some instances, specifically where it makes sense, iron. And now that's recorded for you guys to hear that hierarchy on micronutrients. And notice I didn't mention sulfur as a micronutrient, as it's a calcium, manganese, and sulfur, because the amount of sulfur we need to achieve these high yields, both in corn, beans, and wheat, it is no longer in my book at micro. Here, one of the advantages that you're seeing out of this slide, okay, and we're going to talk about this next week, so stay tuned if you felt like there was any kind of value out of this morning's conversation and want to do the last of the 6 final credits. We'll talk about humics and fulvic specifically, but here you can see the same starter with surge. That surge essentially in this soil profile is creating available micronutrient availability for that plant uptake. Okay. And that slide will make more sense next week when we talk to it. But that's why I show you that with the addition of a fulvic in a starter, a good ortho available phosphate starter. A lot of the yield advancement on that Maryland slide was because that plant found more micronutrient uptake at the right time. We'll slip through here. I'm not going fast, but I want to get the slides I want to see. Again, we talked about that. Hey, now what is it? Well, it's a micronutrient plus macronutrient application at the same time in soybeans. Midnight, I think the slide is in here for that. I'm just showing that these micronutrient blends still have availability against data, yield data. Sulfur, again, just a slide to show you that I'm not making it up when I tell you that corn with more sulfur will usually yield against corn that doesn't have sulfur. Here would be a combined product approach of finding the right nutrient, especially on the secondary or micro that plant needs at the right time, right? So you can mitigate your risk with foliar applications. I will tell you that micronutrients and foliar applications are two separate things. I will also tell you that if used correctly, a foliar application is a good way to apply micronutrients into your plant. Not all foliars are created equal, and not all foliars have the amount of stuff or even the stuff that you need at the right time. Timing is critical. Timing is critical to make these pay economically.
That's also
go ahead.
important. I say that's very also very important to know what growth stage you are at any crop that you're growing to put these things on at the right time.
And that even goes to remind guys that sometimes foliar micronutrients as a herbicide rider, as a fungicide rider, as a crop rider for other applications doesn't always give you the best return, because just because you're out there spraying at a certain time, maybe killing weeds, that might not be the best time for that plant in the right growth stage to respond to the nutrients that you're putting it out there.
Yeah.
So I'm not here to say, oh, you have to separate all your applications. You have to do a specific application for a specific product. I'm just here to encourage anybody that has a chance to listen to this that, oh, if they're one of those guys that have used foliars without success or have used certain foliars and don't see a response, a lot of those guys are tending to mix them in a tank mix of 7, 8, 9 products. We talked about chelation and the importance of that chelation to make sure that those nutrients stay available until you get them to the plant. But 2, we talked a lot about the timing of the needs. Know your crop, know your soil balance, know your yield goal, and then time your micronutrient package or a specific micronutrient based on that, not because you're already out spraying it 2 weeks, 10 days, 15 days ahead of when you really need that micronutrient package. Talked about the importance of calcium again. Sometimes if you can find a good way to put calcium out, even though your soil sample says that you have plenty of calcium, you'll advantage. That is enough for today. Oops. Let's switch this again here and go here and go here. Does everybody see my contact up here one more time?
Yes.
Yep.
There you go. So that I will take questions. If you guys need to percolate, digest a little bit, here's my contact to send them. Joe will have the recording out there with the link and preferably the sign-in sheet for the QR code. Multiple responses last week on the QR code working exactly how it should. Again, I believe nutrient management and a crop management CEU available. And yes, these CEUs in your state should help you with your commercial or private pesticide CEU needs. I think somebody asked a question on that last week. Somebody might ask a specific question to that, so I asked that question to somebody, and that was the answer I got. So if you're working on pesticide or applicator type CEUs, I think sometimes the commercial applicator credits don't count for CEUs, but the CEUs should count for the crop management should count for your applicator's license. Any questions, comments?
No, good job. I could spend hours looking at that.
I think that's when you start pulling the individual nutrients away by themselves and diving into them and understanding either how you were told to use them or how you thought to use them or how you've used them with success on your farm, they turn into an hour individual conversation. You're exactly right. And we wanted to keep moving a little further. There are the main takeaway is there are some abilities in your soil profile to build these micronutrient levels to an ideal part per million as long as you adhere ratios. But also, as we move into higher yielding crops, understanding what that crop needs, when it needs it, and what specific nutrients do to accomplish your goals, it does give you ability to do a foliar type application based on crop need versus expecting it to get what it needs out of a soil. Because unfortunately, with them being the micronutrient segment, they are very susceptible to tie up in the soil profile because they are there in 100 and 200 and maybe even 10,000 pounds of quantity in your 6-inch furrow slice. But again, don't be removed when we say 2 million pounds of soil in a 6.7 inch furrow slice. That's a acre, right? That 2 million pounds of soil can take 200 pounds of zinc disappear in a hurry. So hopefully everybody got something out of it. Like I said, any other questions that guys have, or if you need to get unmuted to ask one, go ahead. Otherwise available. I think we stopped the recording if you haven't already, Joe.
No, have not stopped the recording because I think we're still digesting some things. But you brought out some good points today with those micronutrient slides from this standpoint. And when we're either going out and talking with farmers or dealing with farmers, and I hate to say this, but it's true. So many of the co-ops only get the farmers to focus on NPK because they can apply so much of it, and of course that's a moneymaker. But what we're seeing in those slides is some of these, like boron, is very critical, and usually on all the soil tests you look at, I mean, boron is like extremely low in the soil test. And boron is one of those keys that starts all the rest of them working efficiently the way they're supposed to. But just knowing that as we go forward and we're wanting to achieve higher and higher yields, then farmers as well as us, I think they rely on us. I hope they do as a trusted advisor to begin to look in high detail on as many detailed soil samples that they could get, as well as tissue samples, and see what's actually happening, even though they might have it in the soil, it's not showing up in the tissue, or vice versa. And we've just got to dive in deeper and help farmers understand that, yes, there is a very critical need for adding micronutrients to your soil or to a foliar mix, if that's the case, to help the plant reach its full potential. And that's one of the reasons they struggle of even increasing their yields. I mean, when the co-op says put on more NPK to increase your yields, and it never happens, these are the other things that they're not paying attention to get to that yield.
Yeah, thank you for that. I didn't show one slide that shows that you can grow 240 bushel with just nitrogen, phosphorus, and potassium.
Right.
The other thing I think that it's important that maybe I did forget to mention is not all these micronutrients are recycled in the soil profile. When you grow a big corn plant and you uptake that PK and nitrogen, you combine, you disc it in, the soil biology turns that into available nutrients for your next crop rotation. That's a recycling of nutrients. Boron does not recycle. What goes with the plant stays with the plant. So just because we put on boron this year for our corn and then we grow our beans next year, there is no gallon of boron that's back recycled into the soil profile in plant residue. So that's the other thing why it's important to understand these nutrients and how they affect yield, because yes, you are forced with certain nutrients to apply them every year to every crop, because they're not all of these micros recycle in the sense that we think about the macros N, P, and K doing. Calcium is always available in most every soil that you grow something into. Boron is not. And again, you got to apply it, and it doesn't recycle like potassium does. So that's a great takeaway on just, and I agree with Joe. The one thing that we caveated with this conversation, I'll tell you that copper, boron, zinc, sulfur, manganese, and iron and moly all affect yield, but that's all with the caveat that you're addressing and not in excess of nitrogen, phosphorus, potassium, calcium, and magnesium. Because when you have too much of that, it's detrimental to the micro availability, and we need these micros to raise high yields. Any other comments from guys that are on, or I will I'll look at the phone here one more time to make sure. Questions that came in on Steve sending but we'll talk specific. Steve, I'll get that answer to you directly.
I'm sure I'll have questions. I need to digest it a little bit.
It's a lot today. You're exactly right. It's a lot. It's a lot of nutrients. It's a lot of slides. So percolate it, and then
one of the things I did, a couple things, and that would be, and we've heard it before, you get into some serious imbalanced soils, like Joe was saying, you were saying, you got to maybe turn to foliar to get response until you can get that balance correctly. But then I think the biggest miss for myself in my operation has been foliar has not worked, but you're always trying to do that with a chemical pass. And that's the takeaway I take from this today is, and I've kind of known it, but you don't want to know it because you want to cover it with one shot, one time. And sometimes it's just not going to work that way. If that makes sense.
Yeah, you nailed it. I will pull just for fun if I knew specifically where it was at. But when we talk about some of these uptake slides on his, yeah, when you're herbiciding at a V2 or a V7, right, on certain nutrients, right, boron at a V8, V12, Brian, you're exactly right. But sometimes they just get lumped in. I think the other thing too is, and we talk a lot about midnight, microhance, hey now, cobalt, boron, moly, right? These tank mix of nutrients only because it's a risk mitigation to not only know exactly what your plant needs, but to address them. But at the same time, don't let these nutrients just get lumped into micro packs, right? Because we just talked about, yes, there's a relationship on uptake on certain nutrients needing certain amounts. So it makes sense to put them all together. But also don't just pick a micro pack and then say, oh, I address micronutrients with this micro pack. You got to know what you're trying to accomplish when you're trying to accomplish it. And that'll make that.
Nate, one thing I would be concerned about and hearing you talk about it is maybe some of these micro packs are actually setting us backwards. And I'm not just saying in general I'm saying in general as far as everybody's micro pack. If you have one that's way out of balance and you're putting more of it out there, even though you're trying to target one in that mix, the other one in the mix that's already are at excessive levels may be hindering you, from what I'm understanding.
100%. The other thing to remember, and I'm out here to say, hey, we're third party agronomy today, but we're obviously Monty's sponsored and we have really good products. The other thing with a lot of the micro packs that are offered today, there's a difference between adjuvants and chelation. And a lot of them are protected by as many adjuvants as they can get in there to try to hold solution, soften water, and keep them in suspension for application, versus truly chelated nutrients in a soluble form that will be driven into the plant, right?
Mhm.
So that's the other thing about knowing what you're applying, because chelation and adjuvant, those are two different ways to put micros into a formulation, and we were always going to lean on chelation.
Mhm.
That's why we try and bring the highest quality products to market with the EDTA in it. And what you run into with farmers, of course, this is a price thing, is they've gone with citric acids as a chelator, and they are very inefficient, and they don't have the impact that they do using an EDTA product.
We struggle a lot with that on some of the Western Corn Belt, not to throw anybody under the bus, but some of the most available boron you can get and zinc too, is citric acid chelated. A lot of the planter setups are running it out the back, either with a chain drag or just a total tube out the back. And unfortunately, chemistry and science would both tell you that citric acid chelation, as soon as it hits the ground and Mother Nature touches it, that nutrient's no longer chelated. So you go out and take a nutrient stratification test on some of those soils, and you will see a part per million increase on boron and zinc in the top half inch to half inch of soil. But that's all it ever does, and that's all it ever goes. And unfortunately, it was a chelated nutrient, not the right way in the right environment, used correctly. And now all of a sudden you're building the top half to 3/4 inch of your ground with a pile of zinc and boron. And I'm not even mad about you building your soil. I'm mad about the fact that you got zero yield return on that application because of the way that specific nutrient was chelated and how it reacts on crop demand and being available in the soil profile.
So Nate, you think you're at the end of the program then?
Yeah, I just a plug for one more week of credits here, and then obviously we're working towards our 2025 offering there of if it's a once a month or a bi-monthly opportunity, trying to get our CEU approval up to a year rotation. But we'll talk about humics and fulvics next week for a soil and water and nutrient management CEU. Joe or I will send out the link for next week, Friday's conversation, same time, same place.
Is this next week or into the next month? We're doing 2 in next month. What is it?
I think we have one more Friday. I have one more Friday scheduled for humics and fulvics for CEUs. Yep.
Okay.
And then we'll work on that'll be it for CEUs until potentially, probably January.
Gotcha.
I think. But hopefully we've got 3. The goal, hopefully we'll have 3 really good recorded webinars to share with guys, pieces or minutes or whatever of them. So
yeah, I got you.